So imagine plotting those on a scatter plot. 1 or 0 is on the vertical axis, and number of boats is on the horizontal axis.
But because it's a 0 or 1 outcome, you just get 2 stripes. 1 stripe up top for the ones and 1 stripe down at the bottom for the zeros.
Yeah, and this does not make a good scatter plot to fit a line to. But what we might then recognize is that what we are actually after here is not so much the yes or no, but what we really want to know is what is the probability? What is the probability of sex on the first date if you own 7 boats, or if you own 6, or if you own 0 boats? But probabilities are still a little bit awkward because they're trapped between 0 and 1. And that means that our line would get trapped between 0 and 1 instead of extending on forever in both directions like a regular line should do. So logistic regression uses a workaround. Instead of fitting a line to the probability, it uses odds.
So now instead of being trapped just between 0 and 1, we can have all of the positive numbers and 0 to play with, which is better.
That is better, but of course it still leaves out all the negative numbers. So we do one more math trick. We take the log, the natural log of the odds, because when you take logs, that brings back in negative numbers.
Decimals or fractions between 0 and 1, when you take their log, they become a negative number.
Yes. So in other words, we are transforming our outcome into a log odds because log odds is a nice mathematical creature. So one of the things that the model ultimately spits back to us is an odds ratio.